Okay, so we've looked at identifying features and making the graph of exponential functions. Now we're looking at actually writing exponential functions when we've got a table or a graph. So as we're looking at it, you've got the table here. And when we look, if you notice first, we remember that a value is always our y-intercept. And that b value is the base that, like, whatever gets raised to another power. So looking at this, the first thing I notice is that I actually have my y-intercept there. And so that means I've got my a value. But how to find that b value or that multiplier? So as this jumps up 1 each time, so when we're adding 1, what we can kind of see happens is that these are getting multiplied by 4 as we go each time. So 3/4 times 4 would be 3. 3 times 4 is 12. 12 times 4 is 48, so on and so forth. So every time it goes up 1, it's multiplied by 4, which means that this increase of 1 is causing it to multiply by another 4, which would be basically what happens when you increase an exponent. So anytime it's going up 1, and then you've got whatever is being multiplied here will be your b value. So with that, those are the only two numbers we actually need. And so y, we know, equals 3, which is the a value, times 4 to the x power. Okay, now we've got one where we've got the graph here, and we'll look back at this. The reason so you might be saying, well, how do we notice the difference between this and like a linear function? So on a linear function, we'd be adding the same thing each time. Whereas on this, it's going in the same direction, but instead of adding something to it that's the same, it's multiplying that's the same. Okay. So if you happen to look and say, well, going from 3 to 12 would be adding 9, and from 12 to 48 would be adding 36, then still going from 9 to 36, that's a change of multiplying by 4. So however you look at it, you get a multiple of 4. On our graph, though, it says as the value of x increases by 1, we want to see what happens with the value of y. First, though, I've got this 0.04, which is our y-intercept. So we know that's going to be our a value. Then as I look, looks like I've got -1, 2, and we got 1, 8, and 2, 16. And so should be able to tell by the curvature here that it's exponential. But looking at, okay, what happens as we go from 1 to 2, that's +1. And from 8 to 16, it's like it's getting multiplied by 2, so doubling each time. Same thing from 4 to 8 on this point, and from 2 to 4. So y is going to equal my a value, which is a 4, times 2 to the x power.